Alright, this is the Unit 1, Lesson 2 video. You notice if we look up in the upper left-hand corner of our screen here, this is from Chapter 4, Section 2 in the textbook. And the title of this lesson is Solving Quadratic Equations by Graphing. Again, the first thing we're going to look at are our content standards. So our first standard that we're going to look at and focus on in this lesson is creating equations in two or more variables to represent relationships between quantities. And we're going to graph equations on coordinate axes with labels and scales. Our second content standard says that that for a function that models a relationship between two quantities, we will interpret key features of graphs and tables in terms of the quantities, and sketch graphs showing key features given a verbal description of the relationship. Our mathematical practice that we're going to focus on today is constructing a viable argument and critiquing the reasoning of others. So a viable argument just means a logical argument, something that makes sense. So moving on. Back in the previous lesson, we learned how to solve systems of equations by graphing, and now what we're going to do is solve quadratic equations by graphing and estimate the solutions of quadratic equations by graphing. Here's some new vocabulary words that we're going to focus on in this lesson. Alright, so our first example, this is an example that's going to have two real solutions. So the problem that we have says we need to solve x squared plus 6x plus 8 equals 0 by graphing. So from yesterday, or from the previous lesson, we found that we had to find the a, b, and c values of the equation. So from here, a is 1. Pretend there's an imaginary 1 here in front of the x squared. B is 6, and c is 8. So if we plug those numbers in the formula x equals negative b over 2a, we're going to get x equals negative 3 for our axis of symmetry. And that obviously, again, means that the x coordinate of the vertex is going to be negative 3. So when they made the table here, remember they started with negative 3 in the middle. They went 1 space left, 2 spaces left from here, 1 space right, and 2 spaces right from negative 3. Again, they didn't show this work, but they plugged in each of these x values into this equation, and they got these y values. Notice how, again, for the vertex negative 3, negative 1, that the y values on either side of it are going to be equal, they're symmetric. So they're both 0 here, and then 2 spaces away, they're both 3. So on here, this next page, we have graphed our 5 coordinate points. Here's the vertex negative 3, negative 1, negative 2, 0, and negative 4, 0, negative 5, 3, and negative 1, 3. Notice here that the zeros of the function are negative 4 and negative 2. They're the two places where the graph crosses the x-axis. So the basic thing here is wherever the graph crosses the x-axis, that's a 0. And another way of calling a 0 is calling it a solution. Okay, solutions of the equation negative 4 and negative 2. If we wanted to go back and check our answers just to make sure that they're correct, you can take each of these numbers, negative 4 and negative 2, and replace them with the x variable in the equation. And if you do that and go through the work, I'm not going to go through and explain it in here, but if you go through the work and just think about it yourself, you'll see that the two equations do come out to say that 0 does equal 0 for both of these numbers. And again, that's just the way that you can make sure that your answers are correct after you go through and graph the equation. Okay, here's a problem for you to try on your own. Pause the video for as long as you need. Find the axis of symmetry, find the vertex, make a table, and then graph your 5 points, and then come back here and check which graph matches the one that you sketched on your paper when you're ready. The answer is going to be on the next slide. And the answer to this equation is A. When you graph the equation, you should have found that it had a solution of 1 right here, and negative 3 over here. That's what these numbers represent below the graph. Okay, a key concept from this lesson, there's three possible ways that you could have solutions when you're graphing a quadratic equation. The first possibility is that you only have one real solution, and that happens when the vertex itself is touching the x-axis. You could also have two real solutions, and we already saw an example where that was the case. And you could also have no solutions, and that's when the vertex is not touching the x-axis, and all the points, like for example this one, the vertex is a minimum, and the graph faces up. So obviously there's not going to be any points below that vertex that could ever cross the x-axis and give us a solution. Another possibility for having no real solutions is if you have a negative graph, so like something that looks upside down like this, where I'm trying to trace with my mouse right now. And since that would be facing down and it's below the x-axis where I'm just moving my mouse right now, obviously there wouldn't be any points on that graph that would ever touch the x-axis either. So those are the three possibilities for the amount of solutions you could have to a quadratic equation. All right, example 2 is going to be an example where we only have one real solution. We need to solve x squared minus 4x equals negative 4 by graphing. So the first thing we're going to do here is take the negative 4 that's on the right side of the equation and bring it over to the left side. The way we do that, obviously, we just add 4 to each side, and then we end up with the equation x squared minus 4x plus 4 equals 0 or equals f of x or equals y. Go ahead and do your negative b over 2a. Remember, a is 1. There's an imaginary 1 right here. When you do all that, it appears that we're going to get the value of 2 for our vertex. So we're going to go one space left, two spaces left, one space right, and two spaces right. We plugged each of these values in. Notice that we got 2, 0 for our vertex, that the 1's match, they're symmetric on each side, and the 4's match, they're symmetric on each side. When we graph those 5 points from our table on the previous slide, notice how there's only one spot where the graph is going to touch the x-axis, and that place occurs at the value of x equals 2. So since there's only one x-intercept, that's the only solution. There we go, the only solution is 2. Alright, another one for you guys to check on your own. We have the problem x squared minus 6x equals 9. Go ahead and pause the video, work on the problem, come back here when you're ready to pick your answer. The answer will be on the next slide. And the answer to this problem is A. The only solution, you can look right here, or you can look right here, the only solution is that x equals 3. 3, 0 is our vertex. All right, in example 3, we're going to look at a problem that has no solutions. This is a number theory problem. So it says, use a quadratic equation to find two numbers with a sum of 4 and a product of 5. So the first thing we want to think about is finding two numbers that have a product of 5. So I'm not really, well, let's look at the way that they talk about it here, but then I'm going to probably talk about a different way that I would think about solving this if I was going to just teach it without using this video. So the first thing we're going to do is we're going to say one of the numbers is 4. And because the two numbers have to add up to 4, the other number is going to be 4 minus x. So if you think about right here, if you added x plus 4 minus x, the x and the negative x would cancel each other out, and your sum would be 4. So that's how they have a sum of 4. So those are our two numbers, and then since they have a product of 5, if we multiply them together here, x times 4 minus x, they have to equal 5. We're going to distribute the x, we get 4x minus x squared equals 5. And then what they did here is they brought the x squared over here, and they subtracted the 4x over here, and then at the end they just flipped the two sides. So anyway, what you end up with is x squared minus 4x plus 5 equals 0. We've got that equation. Then we're going to go ahead and graph it. So you'll see that they didn't show the table that comes from this, but if you think about it, you need to do the negative b over 2a. If we look right here, b is negative 4, a is 1. So negative b would be positive 4 divided by 2a. 2 times 1 is 2, so 4 divided by 2 is 2. So you can see here the vertex is sitting on the x value of 2. 0, 1, 2. The x value is sitting on x is 2. Or the vertex is sitting on x equals 2. And if we plug in 2 in this equation, 2 squared is 4. 4 times 2 is 8, so 4 minus 8 is negative 4, plus 5 is positive 1. So our vertex is 2, 1. And notice that a is positive, so the graph opens up. Since this graph opens up and the vertex is already above the x-axis, it's never going to touch the x-axis, and that means there's no solutions. So basically what that means in practical terms for this problem is that it's not possible for two numbers to have a sum of 4 and have a product of 5 at the same time. If you check this, in order to check this, what you would try to do is you would just try to find the products of several numbers whose sum is 4. So we were looking for numbers that had a product of 5. So if you think about ways that you can multiply two numbers together and get 5, the only thing I can think of are 1 and 5. And 1 times 5 is 5, but 1 plus 5 is 6. It doesn't have a sum of 4. And then negative 1 and negative 5. If you multiply negative 1 and negative 5, you get positive 5. But if you add negative 1 and negative 5, you get negative 6. And again, that's not a sum of 4. And those are the only ways you can multiply two numbers to get 5. So clearly it's not possible to have a product of 5 and a sum of 4. Alright, here's one for you guys to try on your own. You need to use a quadratic equation to find two numbers that have a sum of 7 and a product of 14. Pause the video for as long as you need. When you have your answer, come back and move to the next slide and check the answer. And this is kind of a dumb problem because when you give multiple choice, after I showed you an example that has no answers, it would have made sense to pick D from the beginning, but it's not always going to be that way. Alright, we're going to pause here. We'll pick up with example 4 in the next